Hello everybody, my name is Abhay Tripathi. Today we are going to talk of registration in IMS network by a VOLTE UE. So as an example, we'll go through the log files in a Huawei RAN and a Huawei EPC and a Huawei IMS network. So this video is intended for all my colleagues in IDEA as well as people who are involved in protocol testing for either RAN or EPC or for IMS. Right. So let's see what are we going to go through today. The agenda is that we'll verify what is the setup that is there, and then we'll go through the message call flow to understand into the protocol level as to what is really happening whenever VOLTE UE registers into the network. So this is a series of the talks that is there. The next talk would be on once the UE which is registered in the IMS network, how it will make call. But this talk is today currently limited to just the registration of a UE in an IMS network. This video would be available on my YouTube channel as well as on 4gexplained.com. Okay, so let's look in closer detail as to what is there in IMS registration. So what we have got is in one of our circles where we are carrying out LT trials, we have Huawei RAN network. It is on software load ERAN 8.1, which is the latest so far. Then we have got Huawei MME and SNP gateway, which is for the EPC. We have got Huawei IMS. We are using the localized DNS there, which is again from Huawei. It is functioning in one of the blades. Then we have got two UEs. They are Huawei Mate 7 with specialized software on them, and they are VOLTE capable UEs. The circle which is in discussion here is TNC, and for the analysis purpose, the log that will look through the IMSI will have 405852 as the MCC and MNC. Okay, so let's go into the details. What I have got here is a log file which I have got from our this network where we carried out this testing. So we are using GenX Assistant, and I've created a project called VOLTE. So on the second thing that I've got is a trace analysis file, which is a Huawei LMT, which carries the trace from the MME side of things. So within these two things we'll be able to see most of the functions. Some internal details of IMS will not be able to see when the communication between PCSCF or IECSCF or SBC which happens, but I think this will give a fair idea about what entails in a VOLTE registration calls. So what we are going to do is to analyze right from the RAN and the EPC perspective, and then the IMS perspective. So bear with me, the talk may be a little bit longer, but let's see what it does. So in this case, what we are seeing is when the UE powers up, the NAS layer of the UE will ask the lower layers for an attach to be done. Now let's look at this attach request, which is in little bit details. So the attach type is combined attach, which means it is a CS. It is a attach for the PS domain as well as CS domain. Because this was already registered some earlier, so this is there is some goodie which is available here, which is with the UE. Next in this message, there is obviously UE capabilities. It says UEA 123 is there, and EA and then EIA 123. And further on, so this message will contain a lot of details towards what is UE capability and what it is requesting for. In this attach message is also the PDN connectivity request. So this will be used for the default bearer setup, and you can see the value type is initial request. So a new default bearer needs to be created. What is important to see further on in this case is, so I'll ignore most of the things for time being because this should be covered somewhere else in another talk. further on, you see the voice to mail preference for UE usage and settings. So this is one of the IEs in the attach request. What it says here is voice domain preference is for EUTRON IMS PS voice preferred and CS voice as secondary. So this UE is reporting that for voice call it would prefer an IMS network, and then if that is not there, or CS voice call CSFB as a secondary mode. This NAS message will actually trigger in the UE a lower layer RRC connection request, and this RRC connection request will have a cause value of MO signaling. Then the UE then system goes through the regular RRC connection setup process. So let's look in from the eNodeB side of things also. So let me go here. So attach, this was the RRC connection setup which was there before this. So attach request which came from UE. So this is the analysis from the Huawei trace analyzer. Attach request which was a initial UE message. Now in this we should be able to see what is the type of attach request. So it is the same thing as combined attach, and then rest all things are same, as we saw in the RRC connection message. And just for record purposes, PS voice preferred and CS voice are secondary. So this was the initial attach request. Then the MME should send identity request to the UE asking for its IMSI. Now that's what we should see in the GenX also, that identity request asking for the IMSI. Then we should see from UE responding with identity response, which is sending its IMSI. The same should be seen in the GenX as well, because it's a UE based message. So identity response, okay. So identity response, and the same IMSI is there. Then we look at when this has been received, the MME will ask HSS for the authentication parameters. Now let's look through that, because before a thing happens, before UE could be admitted further, the check has to be made from the HSS that this is a valid IMSI. And as part of that, there are various AVP which is being sent towards the HLR to HSS for the information. So username is that IMSI number which was reported by the UE in the identity request, identity response. And it is asking for various data, so you can see through that. Then HSS should reply with the authentication information, and it will provide various parameters like SME and authentication, XRES. Then MME will ask the UE for the authentication with those parameters, random and the authentication number, random number and the AUTN. This should go as the downlink information request, authentication request, and then authentication response. So that should be available here also from the MME side, authentication request going and then authentication response coming in. Okay. Then we should look at security mode command, which would be there. So the security mode command will have the authentication, the encryption and the encryption parameters. So I think it was here, yeah, EA2 and EIA2, integrity protection and encryption parameters. And then UE will respond with security mode complete. So let's look through that here. Security mode command and security mode complete. Now when the security mode command is being sent to UE, the similar parameters has to be sent towards the eNodeB as well. So if you look here, you will find that all those, yeah, this S1 APPDU, you will find the yeah, the protected NAS message that is there, and then uplink NAS message. It is just a message which is enode VID protected NAS message, PRM ID, cell ID tag. So the MME to enode B communication also has to happen. Then once security mode command complete happens, MME has to talk to HSS to update the location register, that yes, where is it located, update the location. It also has to send here, where is this? It will send the UE capability as well, that whether it supports the SRVC or it doesn't support the SRVCC, and homogeneous support of IMS voice over PS session supported. So HSS will update its record and respond with the answer. So I'll go into much details of this. Now after that, MME will ask SGW for create session request. Now before this happens, where is this? Yeah. So there has to be UE capability inquiry. So where is this in this message? Okay, so before this happens, there is create session request which has been done towards the SGW. So in this message we should see, so that's obviously a GTPC message, and the communication towards the MME is being done here, towards the SGW is being done here, create session request. Okay. MZ is there, same 193, MSISDN, ULI is there. Okay, so ULI will obviously contain the TIE and the ECGI. RAT type is EUTRON, which is what we know. Okay, right. Then create session response. SGW will respond to the session which has been created. Now remember that at the start UE mentioned that yes, it would prefer the IMS but also do a CS fallback as a secondary. So that would require MME to update the location of the UE towards the MSC as well. So that is why it is SGS location update request and accept, and in that it will do an MZ. It will mention that yes, it is an MZ attached there, and all the other parameters like ECI, tag, etc. MSC will respond with the accept message. Okay. Then attach accept happens. Now one thing which is important, which I did not touch here, was when the UE capability has been asked. So authentication is UE capability inquiry has been asked for UTRA, GRAN and CDMA. UE responds with all its capability, and it is a decode of large message including the interband and interband capability and other release capability and its FGI, which is here. And after this we should see RRC security mode complete. This we saw earlier. Now this is where the RRC reconfiguration is happening. If we look at it closely, yes. So what is happening here is, as part of the default bearer addition, EPS bearer ID 5 is getting created. Okay, EPS bearer ID 5 is for the default bearer. Connection complete. Attach accept. Now in the attach accept you should see QCI 9 which was there and the EPS bearer ID 5. So that's when the EPS bearer ID 5 is being established, and the UE, the APN point name is test MMSC. Obviously the other details. Now this is the IP address which UE got allocated, which is, so clear 32, sorry 20 is 32, so 20 32, so I think this should be 100 x 51 is 100.81.254.32. So this is the IP address which UE got for its default bearer. These are the details of the details from the UE for the activate EPS bearer. QCI 9, EPS bearer ID 5. Rest all details are same. What it would be important to see is the AMBR, which should be somewhere here. So on the IPv4 APN AMBR, so the DNS address, obviously this is the Google one which has been configured there in the DNS. I'll go up just to see what I'm looking for. APN AMBR is set to 254 Mbps. There's no GBR, so you can see the downlink guaranteed bitrate is 0. No RNA delivery in the delivery order without delivery order. Background class. Okay, now then UE says an accept. Let's look it from this side. After the this thing happens, the SGS location update and attach accept we saw. Initial context setup is happening from MME to eNode B. In this message itself, the UE will be informed, eNode B will be informed by MME that what is the context on the MME side, what is the context on the eNode B side, which obviously we reported before. This is the 100 Mbps downlink and uplink, 50 Mbps uplink, which is there. So the QS which gets negotiated for each UE, it gets informed to the eNode B. EPS error by D5, QCI 9. The GTP-TE ID is there so that the S1 AP communication, S1U communication can happen. It is saying serving PLMN. SRVC operation possible or not possible. In this case, it is possible because the UE says it is. It can support it. Then UE capability info indication. So this was something which happened before on the RAN side, where the UE sought for the capability information somewhere. UE capability inquiry and UE capability information. The same message gets passed on here in the UE capability information from eNode B to MME, so that MME knows as to what are the UE capabilities. Then this is the response, and it says that yes, it has set up the ERAB ID 5, and what is its side of the GTP bearer. Attach complete. So this is what we had seen. Obviously, when the attach complete happen, modify bearer request happens and modify bearer response will be there. PDN connectivity request. So this is the initial. Okay, sorry. Before I go on to this. Okay, so UE capability, RRC, attach accept, default bearer we had created, uplink complete. Okay, next is what we'll have to see is what happens next. Now there is PDN connect. So this, let's look at this RRC connection. I think this should be just measurement, right? So yeah, so these are measurements which get set up on the UE side as soon as the new call happens. So in this case, it was just to set up the A2 and the A2 message, A2 bearers, sorry, A2 measurement events. Uplink information request from MS to eNode B, which has this PDN connectivity request. Now this is where the things start for the IMS. So let's pay a little bit more attention here. Initial request, PDN connectivity request. PDN connectivity request. It is saying you could use either IPv4 or IPv6. Initial request. APN name is IMS. Then it is talking of the protocol configuration option, which is okay, IPCP UE2 this. It doesn't know the DNS address, which is why it's 0, so I think that's fine. And rest all things are the usual part. Now this PDN connectivity request, let's look at from this side. UE sends it, so it's the same PDN request. SGW sends to MME to modify the, oh sorry, this was the previous request and response, so let's ignore that. Now MME has received this PDN connectivity request. It again asks for a new session to be created. Remember, it has done it at the time of default bearer also, but in this case what it is saying is GTPC creation IPv4. So this is for 193 MZ, which is our MZ. MSSDN of that, that's fine. Choice. Fine. So sender field control plane v4 message, MME GTPC interface. Okay. S5 S8 PGW GTPC IMS. Okay, APN name, which is what we saw in the PDN connectivity request. Right, so rest all should be same. So the PDN connectivity request has been asked. SGW responds with that. So where is this? Create session response. We should see request. So cause value is request accepted. Further down, we should see IP addresses. That is fine. 21. PCI max bit rate, so that's fine. So this is only the communication so far which has happened between MME and SGW, and SGW has replied to it. Now the same needs to be informed to the UE. So MME will ask UE to activate this bearer. Okay. Now please look at it carefully here. QCI 5. QCI 5 is being set up for IMS signaling, because that's what UE asked for. UE asked for a connectivity request, so a signaling bearer has to be established first. So QCI 5 is getting established, and obviously this was the APN name which was there. Okay, and somewhere here we should see what is the priority level. IPv4 only allowed, so IPv4 request is there. While this is being sent to the UE, we can look in the GenX PDN connectivity request that was there. And then, sorry, this is response reconfiguration. You can look in this. EPS bearer ID 6 is getting created, and yeah, so EPS bearer ID 6, which is for signaling, which is getting created here. before this happens, at the PDN connectivity request, remember we saw in this here that the ERAB also has to be, the MME has to tell eNode B also to set up the corresponding bearer, right? So that's what would be in this message somewhere. Yes, one AP message. So RAB request, EPS ERAB ID 6 and QCI 5. Okay, so this is for our IMS bearer. Then node B sets up this, sets as a response, which will be success somewhere, ERAB ID 6, and a TLA is being sent. Right now, activate default bearer context request has happened, and context accept would come from the UE. So IMS bearer we saw there. IPv4 only allowed, that's what we saw when SGW was contacting the MME. Right. Accept. Right. So at this point, the bearer has got the default, the IMS signaling bearer has been accepted. Now when the IMS signaling bearer has been accepted, there has to be now the request towards the, so let me show this in a simplistic format so that it is clearer. So after the default, the bearer has been set up for the IMS signaling. Now there has to be a register message from the UE which will not contain any authentication parameter. IMS will respond back giving its nonce with saying that it is not authorized. It will provide some authentication parameter. UE will respond with another register message, this time with the authentication response, and this should be okay. Sorry, I have not mentioned it here. This should be okay. Now let's look at this message in more detail in this. So 1346.33.274. After that would happen after the bearer context has been accepted. So after this 33.235.33. After this, you will see the first request message from the UE, which should say register. Now, if you look in this register message, from the SIM itself, the UE will determine its IMSI number and it will append these things: ims.mcc.mnc.3gppnetwork.com, and that will be in this authorization digest also as realm. So realm ims.mnc.mcc.3gppnetwork.com. So this is the sequence number 1, which is for registration, and there is no authentication parameter within that. If you look at it, nonce is equal to 0 or null, and response is null. So this is the first message which goes from UE towards the PCSCCF, or for practical purpose we can say IMS. Now within the various nodes, the PCSCF will contact ICSCF and will try to fetch the details from the HSS, which you should see here. So there it will be it will fetch the authentication details in the message which is 401 unauthorized from the IMS towards the UE. You will now see these authentication parameters, nonce, and also the algorithm which UE has to use, aka MD5. Okay. UE will then compute all its use this authentication parameter to compute the responses, and will now send, see, this is now sequence number changed to 2 register, and it will now send the nonce message. It will send its username and realm, obviously, for it to know. So the authentication parameters is being sent now. system will respond with register OK. IMS will respond with register OK. So at this point the UE is registered. It is also trying to say what all subscription that it can follow. You will see all point in time there will always be the from and to. So you'll see the ims.mnc.mcc.com. So that is the UE's ID. You also see in all these messages, sorry, I should have explained this. In the first message itself, you would see the UE IP address and 5060. So it will start by communicating for the signaling message from the UE side. It will contact on 5060 port number and 1081.254.31. Now where did this IP address come from? Let's look at it closely. So we should see in the default bearer activation, we see this PDN address. So if you look at it closely, so 64 is 100, sorry, 64 is 100, then 51 is 81, then FE is 254, and 33 is 51. So that's the address which was there, which gets allocated when the IMS bearer was being set up, IMS signaling bearer was being set up. That's the message which is being used by the UE to say please contact me on this IP address and so port number. Okay, so that's how one gets the IP address for the UE, and then the subscribe request happens, so that UE try to request to the network that yes, these are the events which I want to subscribe. There is 200 OK which comes in, and notify is like if there is anything for me, please notify me. So in this case, the same MSISDN which is being used, and this event is getting created. Right, so created, active. So these are the various events which gets created for the registration, and then notify OK happens. At this point, UE is now fully registered into the IMS domain. Now let's look at it. I will also mention something more here, which is obviously not part of the IMS registration, but because I've got it in logs, so I might as well explain that. So default bearer context request, contact accept. This was for the for your IMS. Now look at this. This is UE context release request from eNodeB to MME. The last message was at 1621. In our eNodeB, we have got 20 seconds as the inactivity timer. Now at this point, because it was just registration, IMS registration, and no subsequent call, so after 20 seconds of inactivity, the eNodeB request MME to release the context, and it says cause user inactivity. So we can clearly establish that how many times a session would get released by looking at these cause values from the MME side or eNodeB side. So MME will, because eNodeB has requested for UE context release, MME will ask SGW to release these context but preserve it. So access bearer request, sorry, where is this? Yeah. So GTP message, access bearer release request. SGW will respond by responding that yes, the bearers that you have asked for removal, I have suspended it. Value request accepted. Okay. Then at this point in time, MME will ask eNodeB to release the UE context cause user inactivity, and then eNodeB will say user context release complete. At the same time, on the UE side of the things, we should see, it's not here, so this is for MS2 happening, so we can ignore that for time being here. RRC connection release, and this release is cause value others on the radio. But on the network side, on the eNodeB side and on the MME side, you would find that the release is user inactivity. So this completes the process of IMS registration by the UE. In this log I've got the similar thing for MS2 also, so we can quickly look through that. So this is where you have to look at IMS2. It will again go through the register process, 400 unauthorized. Now this nonce is there, then request, this time second message request which contains nonce, and then register OK, and then subscribe and notify. So this completes the talk for today. Next talk will be on the SIP call initiation. Okay, good. Thank you.